Today, we're going to be proving triangles congruent using SSS, SAS, ASA, AAS, and HL, which is a continuation from last class. We will be able to use a limited amount of information about side lengths and angle measures to prove triangles congruent. We will be able to use coordinate methods such as distance and slope and algebraic methods to prove triangles are congruent. Before we start on these notes, on the left-hand column of your note sheet, there's a space for you to recall the 5 congruence postulates or theorems to prove triangles congruent. Go ahead and pause your videos to write those down and sketch a picture of what those would look like. Now, sometimes when we're dealing with proving triangles congruent, we need some extra information from previous units. If you look at this first pair of triangles, we have these little arrows on the lines which tell us that these two sides are parallel to each other. And they have this transversal here that touches both of them. And that information tells us that these two angles are congruent because they are corresponding angles. Similarly, these two sides are parallel, so these would also be corresponding angles. In our second set of triangles, we have this parallel line with this line, and they have this transversal that touches both of them. From that, we can determine that this angle and this angle are congruent because they are alternate interior angles. We can also use the fact that these angles are vertical angles to prove that those are congruent. And in our third picture, technically we have two triangles that look like this, but they've been stuck together. They share this side, which means this side is congruent. They're the same. This is, we know, because of our reflexive property. So along with the new theorems that we've learned to prove that triangles are congruent, we're going to have to use some of the information we've learned in previous units to help us. Now, today's goal is to complete the proofs. So what exactly is a proof? For us, in this unit, a proof is what is congruent and why. As far as the setup for our proofs go, the what is congruent part are our statements, and our whys, or how we know that they're congruent, are the reasons. So let's look at our first proof for today. Given that AB is parallel to CD and angle A is congruent to angle C, prove that triangle ABD is congruent to triangle CDB. Now, like last class, we're going to start by marking our picture. AB is parallel to CD. That's actually already marked on our picture for us with the triangles. or sorry, with the arrows. Angle AC is congruent to angle, sorry, angle A is congruent to angle C. So let's mark that on our picture. Since we were given this information, we're going to write that down in our statements. AB is parallel to CD. The reason we know that is it was given. And angle A is congruent to angle C, which was also given. Now, since AB is parallel to CD, and they have this transversal that touches both of them, we know that the alternate interior angles of B and D are congruent. So now, since both triangles have an angle B and an angle D in them, we're going to use their three-letter names in our statement. So we know that angle ABD is congruent to angle BDC. And the reason we know this is alternate interior angles are congruent. And proofs can be a lot of writing, so I like to use some of our symbolic notation to help us out. Now, because these two triangles are stuck together and share the side BD, we know that those are congruent because of our reflexive property. Now looking at our triangles, we have two angles and one side marked. The question is it angle, side, angle, or is it angle, angle, side? It may help you to separate the triangles. And transfer the markings. A, and C are congruent. ABD is congruent to BDC. And we knew that side BD was congruent for both of them. So based on these pictures, is it angle, side, angle, or angle, angle, side? Hopefully you said it was angle, angle, side. Angle, angle, and the side that we knew was congruent was not inside the other angles. Angle, angle, side. So we've just proven triangle A, B, D is congruent to angle C, D, B by the angle, angle, side theorem. Now, one thing that can be a little tricky about these proofs is using other information, you could have gotten that there was a different theorem for them being congruent, and you would have had a couple different steps in your proof. There's more than one way to do many of these. So let's look at another proof. Given that AB is congruent to DB, and C is the midpoint of AD, prove that triangle ABC is congruent to triangle DBC. So again, we're going to start by marking our given information. AB is congruent to DB. That's already marked with us with the double tick marks. And C is the midpoint of AD. Since this is the middle, we know that AC is going to be the same length as CD. And we'll come back to that in a minute. So we know that AB is congruent to DB, and that was given. Now, an option is also that you can put all your given information in the same line. So we also know that C is the midpoint of AD. So sometimes you'll write them separate. You can also write them together if they're both given. Next, we determined that AC was congruent to CD. And we knew that because C being the midpoint means that these are equal. So our reason is the definition of midpoint. Now, what else in this picture do we know that might be congruent? Well, both triangles share the side BC, so we also know that that's congruent. BC is congruent to BC. And what helps us determine that? That's our reflexive property again. Based on our picture, can we determine that these two triangles are congruent? We can using the side, side, side theorem. Triangle ABC is congruent to triangle DBC. And our final proof for today. This proof is going to be a proof of algebra and coordinate geometry. We're not going to write down the statements and reason. We're going to prove it with algebra and numbers. So, given the two triangles, which have already been graphed, and given that H is the midpoint of PR, prove that triangle PVH is congruent to triangle HQR. So I'm going to start by using these coordinates to help me label my picture. So -2, -4 is P, -1, -1, 2 is V, 1, -2 is H, 2, 4 is Q, and 4, 0 is R. Now, we also know that H is the midpoint of PR, which tells me that PH is congruent to HR. Now in this one, we don't know anything about the angles. So we're going to prove that they're congruent using the sides. So what we need to do is determine the length of PV, VH, HQ, and QR. And if you recall from previous units, we can determine the length of a line segment using the Pythagorean theorem. So Recall that that is c squared equals a squared plus b squared. So for PV, c squared would equal, we go up 1, 2, 3, 4, 5, 6, and over 1. So a would be 6 squared plus 1 squared. If we simplify this, we get that c squared equals 37. So c is the square root of 37, which would be the length of PV. For VH, we go up 4 and over 2. So c squared equals 4 squared plus 2 squared. If we simplify, we get that c squared equals 20. So c equals the square root of 20, and that's the length of VH. HQ, we go up 1, 2, 3, 4, 5, 6, and over 1. So c squared equals 6 squared plus 1 squared. So c squared is 37, which means c equals the square root of 37. So HQ equals the square root of 37. Now, look at our congruence statement. PV and HQ, the letters are in the same order, so those segments should be equivalent. Does PV equal HQ? It does. They both equal the square root of 37. So we know that PV is congruent to HQ. What about QR? 1, 2, 3, 4, and over 2. So c squared equals 4 squared plus 2 squared. So c squared equals 20, or c equals the square root of 20. In our congruence statement, VH and QR are in the same order. So we want QR to equal VH, which they did. They both equaled the square root of 20. So QR is congruent to VH. Therefore, triangle PVH is congruent to triangle HQR because of side, side, side. QR and VH were the same, and PV and HQR were the same. For your summary, why is it useful to write a 2-column proof? Fill in your summary, and we'll see you in class.